This problem wants us to find an equation of the tangent line to the graph of y equals negative 4x over x squared plus 1 at the origin and at the point negative 1, 2. So we need to find the equation of a tangent line. Let's consider the form of a line, slope-intercept form we'll use, y equals mx plus b. And in order to get this form evaluated, we're going to need slope and the y-intercept. The slope being the m, the y-intercept being the y-coordinate, or the b being the y-coordinate of the y-intercept. So in order to find slope, oftentimes in a pre-calculus course, you got 2 points, and then you do y2 minus y1 over x2 minus x1. Here we only have a single point. In a calculus course, you go to the derivative to find slope. So we're going to need the derivative in both cases if we want the equation of the tangent line at both these points. So our equation is a quotient, it's a fraction. So we'll use the quotient rule to find the derivative. I'll notate the derivative as dy by dx. And for the quotient rule, we're going to write the denominator, which is x squared plus 1, times the derivative of our numerator, which is just going to be negative 4. This makes up the first term here. And then we have a minus sign, and the second term of our numerator is going to be the numerator, negative 4x, times the derivative of our denominator, which is 2x. And then both of these terms are written over the denominator squared. That's just applying the quotient rule to find the derivative. Now we don't necessarily have to, but it might be helpful to simplify this a little bit and make it easier since we have to evaluate at 2 different points. So let's see here. If I was to distribute the negative 4 into this binomial factor, I'll get negative 4x squared minus 4. For this second term, we have 2 negatives, which makes a positive, and then I've got 4 times 2 is 8. And then x times x is x squared. And then we could simplify these these 3 terms. We got a common term here in our x squared. So we got negative 4x squared plus 8x squared. That's 4x squared. So I'm going to write this as 4x squared minus 4. And then again, this whole thing is over x squared plus 1 squared. So there's our simplified derivative. And we're going to use this to get the slope. The derivative is a function for slope at any particular value at x. So if we consider our first point the origin is another way of referring to the coordinate point 0, 0. We need to find the slope at x equals 0, because that's the x value. So we'll evaluate our derivative at x equals 0. So if you're to plug in 0 here, you're going to get a negative 4 up top since the first term goes away. Down below you get 0 squared plus 1, which is just 1, and then you square it, it stays 1. So our slope ends up being negative 4. So we have y equals negative 4 is our m, x, and then this b is the y-coordinate of the y-intercept. We know we're dealing with the y-intercept when we have an x value of 0. In this case, when x is 0, y is also 0, which means the y-intercept is 0. So this is actually the equation of the tangent line at the origin. Another option people use to evaluate if you have the slope and a point to get the equation of a line, you can evaluate what's called point slope form, which looks like this, where x1 and y1 are just the coordinate points given. So I could say, well, this is going to be y minus y1, which is 0, equals m. We found m to be negative 4, and then parentheses x minus my x coordinate, which was 0. And then if we solve for y here, we've just got simply negative 4 times x, and then this y minus nothing is just y. So again, we get back to that equation of the tangent line that we found. So that is, again, the equation of the tangent line at the origin. We can do it again for the other point given, which was negative 1, 2. So if we're going to find the slope at this point of our tangent line, we need to evaluate our derivative at x equals this x value, negative 1. So if I plug negative 1 into my derivative here, I'm going to get negative 1 squared is a positive 1 times 4 and then minus 4. So I end up with a 0 on top. So assuming the bottom's also not also 0, which it's not, you plug in negative 1, you end up with a positive 1 here, and then you add 1, you get 2, you square it, you get 4. Right, our slope's just 0. So we have a slope of 0 at the point negative 1, 2. Which means the y value is never going to change, so we could just go right ahead and call this y equals 2. All right, y equals 0, x plus 2 is just going to, of course, be 2. Alternatively, we could go back to that point slope form, or sorry, I keep saying that wrong. I did it right now. Point slope form is right. We could evaluate this point slope form. Y minus, in this case, the y value is 2, equals, we just found our slope to be 0, in parentheses x, minus our x value is negative 1, so it ends up being a plus 1. If we solve for y here, the whole right side zeroes out, so we'll just add 2, and then we end up with our y equals 2 as the equation of our tangent line at the point negative 1, 2. So these are the two answers for this problem. Hopefully you find that helpful. Thanks. Bye.